Hi everyone, welcome back to our YouTube channel Electro Study. This is lecture series 23 under computer networks dealing with User Datagram Protocol, simply known as UDP. This protocol works under transport layer. Please do like, share, subscribe and comment. Come, let's go into the video. So, Datagram Protocol, we tell this protocol as a very simple protocol, and also it is a connectionless protocol. It provides connectionless services, and it is also said that it is an unreliable protocol. That is, it provides unreliable services. But still, why do we require the UDP protocol? It is deployed where the packets require large amount of bandwidth along with the actual data. Not alone the data, it also includes the large amount of bandwidth. Say for example, like in video streaming or when you are seeing movies, it acknowledges thousands of pockets, and it is tough to acknowledge such number of pockets, and there will be waste of many bandwidths. So in that case, you obviously need this UDP protocol. And this UDP protocol has some features like it is designed to send data packets over the internet from the client side to the server side. It also provides the process to process communication. It doesn't look on to host communication. It is using process to process communication. And also it performs a very limited amount of error checking. It doesn't provide any particular field for controlling the error. And this protocol, it uses the minimum number of overheads. See, in other videos we have seen an actual data carrying a header and a trailer. Likewise in UDP, it does not provide a many number for the overhead. Only a small bytes is allocated for your overhead along with the data. And this protocol simply takes all the datagrams from the network layer and attach the header and the tailor, required header and the tailor, and sends back to the user as and when required. So these are the some features used by the user datagram protocol. Now in this, you will be seeing the datagram, design of the datagram. You have an actual data with a header where the header is is the size of the header is 8 bytes, and the size of the header is fixed. And it has, see, this complete data is divided into four. That is the source port number, destination port number, total length and checksum. So you obviously know what all these belongs to. Rather, I will be describing you in detail. And in user datagram, you could see another header called as UDP pseudo header. What this UDP pseudo header does is it checks whether all the datagrams or pockets formed from one end reaches to the destination perfectly. There is no error that has happened or any losses that has happened. That is why UDP pseudo header is being used. So if suppose if checksum does not include, see, in UDP checksum is not must. So user datagram may arrive safe, may not arrive safe. So however, what happens is if the IP header is corrupted, it may be delivered to a wrong host. So this protocol field what it does is it is added to ensure that the pocket belongs only to the UDP and not to the TCP. That is, TCP is nothing but transmission control protocol. And the value, there is a value assigned for the protocol field. That value is nothing but 17. Why this value is assigned is, if suppose this value is changed during the transmission of pockets, then the checksum calculation at the receiver end will deduct and the UDP will silently discard the pocket, telling that there is some error that has happened during the transmission. Next is, you will be seeing what is source port number, destination port number, what is checksum and length. So source port number is nothing but it is a 16-bit information which identifies which port is going to send the pockets of data. This is used by the process when the source host is running. When source host starts sending the data, the source port number starts calculating the port numbers, and it is also used to identify the port of the sending or the sourced application. So whether if the data are sent from the source side, that is client side, might be at that time it will identify through which port it has been communicated. Got it? So destination port number is nothing but it is going to identify which port is going to accept the information from the client side. So obviously it is a 16-bit information which is used to identify the application level services on the destination side. So this is, as I said, it is of 16-bit length, and if this destination host is the server, might be if the destination is server and not the client, then the port number is well known, called as the port number. So in this case, if the destination host might be a client, anywhere, client also can be a destination, server can also be a destination. So if a destination host is a client, then what happens? The port number is an ephemeral port number. So server is, you will completely know through which port it has been communicated. If it is a client, it is just an ephemeral port number that we are going to assign. Next is length. So length is also, it is a 16-bit field, and it is an optional field. It is not that you have to include it wherever you want, and it represents the entire length of the UDP packet, not only the actual data. Along with the header, it gives you the entire length of the UDP packet. So the minimum value should be of 8 bytes, as the size of the header is an 8 byte. Totally it is 16 byte, but minimum it should be a 8 byte data. So here the UDP length, how it is measured is the length of the UDP header plus the length of the encapsulated data. So actual data including the header will give you the complete UDP length, which is of 16 byte, and minimum it is 8 byte. Next, checksum. So this is an optional field. What this checksum does is, it checks whether the information is accurate or not. So there will be a possibility of getting the data is getting corrupted, right? So it is checking for it whether it wants to write any checksum or not. If it does not want to write any checksum, then all the 16 bits are made 0. Here you can see it is 0. Right? When it is made 0 is if it doesn't want any checksum to be written, all the 16 bits will be 0. Or otherwise, if it needs to write a checksum, then in UDP the checksum field is applied to the entire pocket, that is to the header also, not only the actual part, and the IP checksum field is applied to only the header field. Got it? So there are some characteristics of UDP that you have to see. So here it is an unreliable and connectionless protocol, as I already told, and it is almost a null protocol. See, it doesn't have flow control or error control with it. It is said to be a null protocol, and if the flow of the data is only in one direction, then it is good for the protocol, because it is dealing only with small data. No large data can be sent through the UDP protocol. So the flow of the data, if it is from one direction, it is easy to make sure that the data is sent accurately. And this protocol does not guarantee the delivery of the data. So as there is no flow control, error control, or any checking mechanism, you cannot guarantee that the data is accurately sent to the destination. And it is a stateless protocol. You cannot predict in which states the packet is being transmitted, whether in full duplex mode, half duplex mode, nothing can be predicted. And this UDP offers a minimal transport services. So this UDP also provides some services like checksum. It determines the length, and it determines the source address, destination address. Some minimum offers it gives. Other than that, it doesn't provide any information. And it also has no congestion control mechanism. That is, it doesn't see whether the network is overloaded or not. Even if it is overloaded, there will be loss of packets, but UDP has nothing to do with. So these are some of the characteristics of UDP. And these are the operations of UDP, connectionless services. That is, these are connectionless services, flow control and error control, encapsulation and decapsulation. So in connectionless services, what happens is the user datagram that is sent by the UDP is becoming an independent datagram. Each and every datagram will be independent of its own characteristic, and it is not numbered, and there is no connection establishment and there is no connection termination. Where the connection starts, where the connection ends, nobody knows. That is why we call it as connectionless services. Next is flow control and error control. So this user datagram being very simple, this protocol being very simple, and it produces only unreliable services, there is no proper error control mechanism that is being followed in the during the transmission of the packet, except that you can have checksum as a one field. Even that is optional. So flow control also, there is a lack of flow control followed in this UDP. So it means that the process that uses the UDP should provide these mechanisms to enhance the accuracy of the packet that is received at the receiver end. And encapsulation and decapsulation. So what happens here is, to send all the pockets, that is messages that you want to deliver from one end to the other end, you obviously need to encapsulate the data and decapsulate the data. You have to encapsulate all the data in one form, send it to the destination. The destination, according to the sequence number, the decapsulated data will be again encapsulated at the destination side. So wherever encapsulation, decapsulation occurs, multiplexing, demultiplexing also may occur. So these are the operations of UDP. Now you will be seeing about the applications of UDP. Now we have seen that it is a very simple protocol. It provides unreliable services. Only small pockets can be transmitted. So what will be the application of UDP? So this UDP is used by those application which requires only one response for one request. If you request only one request, for that request the necessary action has been taken. It doesn't do multitasking, and it is used by broadcasting and multicasting application, and it uses management processes such as SNP to make use of this UDP. And the process that has an error and flow control mechanism, it makes use of the UDP. One application that you can tell is Trivial File Transfer Protocol, that is TFTP. You would have seen about FTTP, HTTP, like that. It is one application called as Trivial File Transfer Protocol, and there is routing protocols that has been followed to tell about the routing information of the datagram, where it is routed, how it is routed, which path it takes. So these are the applications of UDP that you can consider. So hope you are clear with the concept. Please stay tuned for more information. Thank you.